Hi, this is Mr. Vandegrift, and I wanted to do a quick review on populations and resources to mini moon jelly. So you guys have your moon jelly booklet right here. And so I'm going to go through these slides really quick, but you can pause the video at any time to kind of read the details on the slides that you want to. But I just wanted to do a quick review. Remember, we're doing our amplified science. Here's our learning intention and success criteria. And basically started out with a pre-unit assessment just to kind of see where you're at. So we use Clever, and then from there we go in and we click on populations resources, and then from there click on there, and then it'll show you we've got 4 chapters, and then from there we're on chapter 1, which you got 1.1, 1.2, 1.3, 1.4. And so the first was to take that pre-unit assessment, which you guys did. That was lesson 1.1. And there was the multiple choice, the short answer, and we'll kind of return to that. We started to see how much you knew, and we'll end the unit with that. And then from there we did lesson 1.2 on the mysterious moon jelly increase. You got your booklets. There's our learning intentions, our success criteria. And then we talked about that you are kind of acting as an ecologist. You're thinking like an ecologist. And then we start out with a video, if you remember, of a scientist talking about that she studies jellies, she collects them, she looks at the data. You might remember this here. I'm not going to show the whole thing. I just kind of video through it. She talks about her career, talks about how much she likes jellies, how she goes out in the field and collects the jellies, and then analyzes them. We've got the sea turtle eating one of the jellies here. And then she talked about food webs. And this huge bloom, this explosion of these jellies and what was kind of the cause of that. Okay? And then we had some discussion questions. We had some new vocabulary, population, ecosystem. The unit question is key, is why do populations change in size in an ecosystem? Okay, so that's what we should be thinking about. And then you gave some of your thinking or your reasoning of why you think there'd be an increase. And then I shared this really cool thing on the Villela invasion in 2015. I was out surfing and I saw these Villela. They're related to jellyfish, and I didn't see 1 or 2. I didn't see 50 or 100, but I saw thousands and thousands on the beach. I took these photos here. You can see I calculated in this one area there was about 5,000 to 6,000 of these Villela in one area. There's my surfboard, and you can see them. But like, what was the cause of that? So these are real problem scientists are trying to figure out. I took some samples to bring back to class. But obviously, one of the cross-cutting concepts is cause and effect, so it would be wind and shifting currents. And so then we went on to our unit question. We already talked about that. Ecologist. So then you got your letter from the Glacier Sea Research Center. Congratulations on your new position, and you're a part of this team of ecologists, and you have to figure out why are the moon jellies increasing. Okay? And then we went to our simulation right here. Remember how to get to that. And we click on here. We got to play around, run your simulation, ask some questions. But the key idea was this. Within a population, organisms are always being born and dying. And you had some homework to read. And you had life in the Arctic, and then on moon jellies, or the wall-eyed pollock, zooplankton, or algae, or leatherback sea turtles, orca whales, green sea urchins, kelp. So you were able to read that, and you were supposed to annotate those. Then we went back to the simulation. We kind of played around that a little more, asked a couple more questions, ran some of the sims. Again, you're going to be doing a little more of the sims here at home even. And then you want to be able to analyze your results and read what's going on with the population. Is it going up or down? Is there any relationships or patterns that we're seeing? Then lesson 1.3, we had births and deaths in a population. And this is where I think we got to do the, what was it? I think it was the token. Yep, the birth and death token model game. So again, you were able to remove if was dying, and then you added if representing births. And so you were supposed to make the population stay the same, make the population increase over time, and make the population decrease. That was kind of the mission of that. And then I think you were over here graphing it right here. And this was a really good video just talking about even though water is being added,
This is a
draining
system.
out down the
The
bottom.
system is stable, meaning the
So it's
level of
stable,
liquid
so there's a
isn't
lot of
going
water
up
going
or
in,
down.
but there's the same
But
amount
that
of
doesn't
water
mean that
going
nothing's
out,
happening in this
which keeps the
system.
level
This
the
top valve
same.
allows liquid to be added to the tank.
And we said that if you clamp down on the bottom and less water is going out but more is going in, then the water is going to rise up. Or if you let less in and then open the valve at the bottom, then more is going to leave than it's going in, and then it's going to go down. And that was related to same as deaths and births in an ecosystem. So the key idea is this: a system can be stable even as things are being added to and removed from it. If the amount being added and being removed are not equal, then the system will change. And then here's just a little review, some pictures of you guys doing the models with the tokens and learning and discussing. Let's take a look right here.
Now we're gonna wanna. So this is 13, right?
So if this is 6,
We're gonna have to get 13
total.
again.
Okay, so now we're gonna have.
Hey Theo, can you explain what you guys are doing?
So we're playing a game where we have to keep the birth to death rate the same. So what you have to do is you start with 14 tokens on the board, and however many you have to take away, you have to add more. You can either add 1, 2, or 3, or you can take away 1, 2, or 3. So what we did is we added 1, and then we took away 3. So that means we have 12 of the tokens or organisms. And then the next year, we added 3 and took away 1, so that means we have 14 organisms.
Thank you.
All right, thank you, Theo. Great job sharing there. And you can see the population going up here. You can see the population going down here, and you can look at these numbers to see what's causing that. You should be looking in your booklet as this review is going over, and you're going to get a lot more out of this. Then we reviewed the water model again, what would make it go up, what would make it go down, what would make it stay the same. So the key concept is if the number of births and deaths in a given time are equal, then the population size will be stable. If there are more births than deaths in a given time, then the size of the population will increase. If there are fewer births than deaths, then the size of the population will decrease. And these pictures, go ahead and take a look at those, kind of represents that as a model. And then we talked a little about the world meter. You can go on there and see the population of planet Earth just going up. It has the deaths and births worldwide, and as we are increasing as human population. Also on the world meter, I believe you can go take a look at COVID-19 virus pandemic around the world and see what's happening for cases on a real-time basis. Then we went on to lesson 1.4, and 1.4 was dealing with the honeybee population decrease. It opened up with that warm-up. And the question was, how do ecologists figure out the population of different organisms? So again, we showed another video here of how the marine biologist, she would go out. They would use nets to collect the jellies, but that wasn't that efficient. Just one little net there. So what they would do is actually use a bigger net, drag it out to do a field sample, and they would get quite more individuals, you can see right here. And so what they would do is test at different sites. And so here we go. When it comes to evidence criteria, samples that represent as much of the whole as possible provide stronger evidence. So you want to be in page 130 in your booklet. That's Population Resource Glossary. Now, they gave some examples here at Glacier Sea that if you were taking samples from one place, and that was taking place every year between 1980 and 2010, then this is what they estimated over the years. Take a look at this graph. What's the population doing? Is it going up, down, or staying the same? Right, you can see it's going up. But take a look at this next right here, and you can see that here there were 8 sites that the jellies were collected or sampled every year between 1980 and 2010. And again, take a look at the graph over here. You can still see it. It's going up. But because there are 8 different sites, Excuse me. So glad that you're so glad that I'm here and you are there and we are social distancing. We're keeping our space and you're safe and I'm safe. All right, I'm fine. All right, so anyway, take a look right here. You can see that it is going up, but because there's more sample sizes, the evidence criteria is going to be much stronger because there's an increase in sample sizes. And you can see that for the most part, it's staying pretty stable until about 2000, dips down a little, and then it shoots back up with this exponential growth right here. And so the big idea is that counting more jellies at different locations provide a better representation of the entire jelly population. So if you zoom in there, you're going to get, it's kind of like having a more powerful microscope or telescope. You're going to be able to zoom in and see more details. So then we asked you to create a graph, or I'm sorry, a model. And so with this, you were creating that model. I think it was for, this one might be for, yeah, the jelly population. And then the first claim was this. What could have caused the size of the moon jelly population to increase? Well, one claim could be the births increased, or two, the deaths decreased. And these models represent that. So your job is to figure out, with evidence, which claim is going to be true. And then we ended chapter 1 with how ecosystems clean Earth's water quiz. So let's do this really quick. I'm going to ask you a question. This is the article here. So if you want to pause the video and read over that 2-page article, I would pause the video right now, read over that. Then when you're done, let's go ahead and take the quiz. All right, so here's question 1. What is an ecosystem? Pause the video, say what you think it is, and turn the video back on. All right, remember, question 2. List 2 ways ecosystems are useful to humans. Question 3. Explain why biodiversity is so important. Question 4. Healthy ecosystems provide many services to humans, including filtering water, or the filtering of water, yes. And how do wetlands filter water? How do the oceans filter water? Again, look at the picture, because I usually put a little clue in there. And 6. How do forests filter water? And then last, what is an ecosystem service? Give 3 examples. And again, you can look at the graphic here to give you some hints. So hopefully that was a review of chapter 1 of the populations resource and 2 mini moon jellies. So hopefully that's helpful. I'll do a quick review of chapter 2, and that should give you a review and get you ready to finish chapter 2 and on to chapter 3. So I hope this video was helpful.